we need to talk about acids and bases. This is not an important property of water, but it is related to water. By the way, two words I just want to throw in. Things that like water are called hydrophilic, and things that don't like water are called hydrophobic. Later on when we learn about cells, these two words are much more important on that chapter than this chapter. Water can dissociate into what are called acids and bases. Molecules are always on the move. They don't stand still. To our eyes, it may look like they aren't moving, but at the microscopic level, they are. As molecules move, they are creating and breaking bonds, and that process we call earlier chemical reaction. For water, a very small amount will convert into a hydrogen ion and hydroxide ion. Then as they move, eventually they collide with other water molecules and eventually convert back into water molecules. But there always will be a small percentage of water in the state of hydrogen ion and or hydroxide ion. Because water is so neutral, we hardly see these ions. In other substances like orange, there are more hydrogen ion, H+, and things have more H+ are considered acidic. This holds true for the opposite. Stuff like milk and household bleach have much more hydroxide ion, OH, so they are considered bases. Things that are very acidic or very basic are very dangerous. Scientists come up with a measuring tool to determine how acidic or how basic something is, which is called the pH scale. The scale is from 0 to 14, with 7 being neutral. 0 is very acidic like car battery, and 14 is very basic like oven cleaner. Each pH number represents 10 times greater. For example, water is neutral at 7. Something that has a pH of 6 is 10 times acidic as water. Something that is 5 is 100 times more acidic. Going down to 2, it's 100,000 times more acidic, like acid rain. Acid rain is very dangerous and can destroy many things. Acid rain is a result from pollutions from smog such as factories and cars. You may have heard in the news people splash acid and it burns. Acid has a lot of H+, and H+ wants to seek out electron to become neutral. So when acid hits the skin, it seeks out the electron in the skin, thus ravaging and destroying the skin cells. The food we eat alters the basic and acid in our body. Fortunately, our body has a buffer, a substance that produces H+ or OH- depending on what we are low on. So a buffer is designed to minimize changes. Alright, we are done with water. Our next subject will be about carbon. There's not that much important things here, because in the next few chapters, everything we learn will involve carbon, so it is a learn as we go along kind of thing. First, let's review.